be very difficult if I don't start the second year now. I'm going to start ray optics. In next because ray optics alone, daily if I take 2 hours also, I require 1 month to complete ray optics, optical instruments, and related numericals on it. Okay. So ray optics actually is very important for your JEE mains. Uh, so let's start ray optics. Okay. Yeah. Can you see the PPT?
Yes, sir.
Yes, sir.
Okay. So we're going to start ray optics. See, as such, when you look at wave optics, we have seen that the light, okay, light is nothing but an electromagnetic wave which is in a visible spectrum of the total EM spectrum. So when we have seen wave optics, we have considered the light to be a wave, and then we have studied your law of reflection, law of refraction, and then we have seen your interference and diffraction patterns, right? So interference, we have mainly have seen your Young's double hole experiment, right? And from there we have calculated your path difference. And we said whenever the waves are interfering constructively, we'll get a bright fringe. And whenever waves interfere destructively, we are getting a dark fringe. So phase difference equal to n lambda. It is a constructive interference, and n plus half lambda, it's a destructive interference. Correct?
Yes, sir.
So we from that interference patterns, we have seen that on the screen you have an alternate dark and bright fringes coming, and we have also calculated the fringe width, the angular dispersion fringe width. Formula is
YD, YD by B.
Y.
D by B.
D by B.
Please, next 5 seconds you have to tell me the fringe width formula. That means you are not studying your formulae. Right, and then part difference is
Lambda D
D
by
by
B.
D.
part difference is
Y D by D.
YT by B, part difference. Very good. Lambda D by D will, we have used B, no? Lambda D by B will give you your points at which you have your interferences. Bright fringe will be at 0, comma,
Lambda D by B, 2 lambda D by B.
3 lambda D, lambda D by B, and so on. Your dark fringes you will have it
3 lambda D by B, 5 lambda D by B. So 7, 9 then. That's
yeah. So that's where you get. And what is your fringe width? Fringe width? Lambda
D by B.
D by
how can it be YB by D? Use your common sense when you're answering it. That's why I said remember the derivative part of it. If you remember the derivation part of it, then it will be easy for you. Then we have seen optical part. Then we have seen your thin film interferences. Then we went to your diffraction. Diffraction, we have seen your Fraunhofer's diffraction, Fresnel's diffraction, isn't it? Fresnel distance is?
Z is equal to
Z is equal to?
lambda by B.
square by
Huh?
square by D, sir.
V square by lambda.
So the basic difference between Fraunhofer's diffraction and Fresnel diffraction is?
So it is kept in infinite distance and this is near distance.
Yes. Fresnel is in finite distance.
Finite.
The source and the screen and the lens as such are at finite distances.
Yes, sir.
Fraunhofer's diffraction, basically the source is at infinity. Okay. Then we have seen polarization, law of Malus. We have done n number of questions on polarization. I don't know if you remember it or not. Right? First time it goes, the induces by 2, and after that the intensity remains same. It's just the angle changes. What is your law of Malus?
I is equal to I naught cos square.
I is equal to I naught.
Cos square theta. Phi. Sorry.
What did I use exactly? Theta or phi?
Theta.
What is your theta angle between your oh my goodness. Brewster law.
Tan I is
Tan I is equal to mu.
where I is like basic is 53.2.
Yeah, if it's a liquid and air medium, then it will be 53. Or else, whenever your refractive index changes, your Brewster angle also change. Polarization, law of Malus, we have done many questions. You still don't remember that. Now, we have seen your electromagnetic wave, which is in visible spectrum, which behaves like a wave, will give you interference and diffraction patterns. Okay. What came first? Wave or ray? Actually, wave came first and then ray optics came. Okay. So, why actually they taught your light to be also as a ray? The only experiment which was responsible was your photoelectric effect. Your second year electromagnetic waves, no, dual nature of radiation and matter. When we'll study your photoelectric effect. Actually, that is where your Einstein has proposed your light to be of a particle nature. Okay, and before that, everybody thought your light is like a wave nature. So now, whenever your light behaves like a ray or a particle, then we will be able to explain many things. Okay. So that is how you are right now, your sensors which are there, right? Light sensors. They actually work on your, ray optics concept only. Understood? So as such, now we are going into a domain where your light is considered to be a ray. A ray means something which goes in a straight line. Clear? Now, I don't know if you have heard the scientist by name Euclid. Okay, Euclidean geometry. Okay, Euclid, he studied light and he wrote in his book Catoptrics about light. Okay, so he stated that whenever a light is reflected from a mirror, he said the angle of incidence is equal to your angle of reflection. After so many centuries, then Newton came. Okay, so Descartes is the one who proposed, okay, corpuscular theory. But Descartes was not able to explain certain concepts in that. So then Newton came and Newton proposed and explained and actually developed the corpuscular theory. Okay. So what Newton proposed is light consists of small particles called corpuscles. And whenever the light is going and hitting the mirror, it's like a ball, goes, hits and comes back. Okay. And Newton is also the first person to propose that speed was greater in water or glass than in air. Okay, this was later explained by Snell. You know Snell's law, right? What happens to your what is the relation between your refractive index and speed?
So directly.
Directly? Tell me your Snell's law, Amma. Mu1 by mu2 is equal to sin I by sin R is equal to
V1 by V2.
V1 by V2 is equal to
Lambda 2 by
Lambda 2 by
lambda.
lambda 1.
uh, at that time only I said your frequency remains same, isn't it? Because your velocity is changing and your lambda is changing, hence your frequency will remain constant. Understood? So now somebody asked Newton, okay, if light consists of particle and light is going and hitting the mirror and coming back, then why there is no loss of weight? Because obviously it is losing particles. So this Newton was not able to explain it, so he left it like that. Okay, understood? So later we came, so basically we still take Newton law only that light consists of or particles basically. Okay, and all your classical mechanics concept can be attributed to your particle nature of the light. Remember this statement very clearly. All the concept of classical mechanics can be attributed to your part of light. That means you can attribute your momentum concepts, you can attribute your energy concepts and all that. Clear? You can attribute your relative velocity concepts. Okay, clear? Now, whenever we talk about light as a particle nature and light as a ray, okay, light is going and falling on something, it's getting reflected. Now, what do I mean by reflection? Okay, so that is first thing what we'll see. For that, what we will take is we will take a very smooth surface and we will take an irregular surface. Okay, so whenever light is falling on a smooth surface, it gets reflected back, and at that time your angle of reflection is equal to angle of incidence is equal to angle of reflection. This is called as specular reflection or regular reflection. But if your surface is not smooth, it is irregular, then your angle of incidence is not equal to angle of reflection. This is called as diffuse reflection or irregular reflection. Clear? Specular or regular reflection, diffuse or irregular reflection. Okay, clear? Now,
Yes, sir.
see, the reflection, as I said, your path of the light will change without any change in medium. That means if your light is coming and falling, for example, light is traveling, it goes, hits, and again comes back in the same medium, then that phenomenon is called as reflection. Clear? Now, if you look at my face, you can see a green dispersion on my specs, isn't it? Correct? That is because of reflection. Clear? So, whenever light travels medium, after reflection, again comes back to the same medium, then that phenomenon is called as reflection. Clear? So there are two types of reflections. One is your specular reflection, the other one is your diffuse reflection. So by that time it is evident that your specular reflection means your surface is very smooth and your diffuse diffuse reflector surface is uneven surface. Clear? Shall I go to the next slide?
Yes, sir.
Now, since we have understood what do we mean by reflection, now let us see what are the laws of reflection. Okay. The first law of your law of reflection is your angle of incident or your incident. First, we'll talk about first law: incident ray, reflected ray, and the normal of that surface always lie in the same plane. That is what is your first law. Now, you have seen here, this is your surface, this is your incident ray which is coming like this. At this point it is hitting. Now, what I will do is, at this point, I'll take a normal for this surface. This is your reflecting surface. Okay, this is your reflecting surface, this one. Now for this surface, I'm going to take a normal. So obviously this is your normal to the surface, right? So this angle of incident ray, reflected ray, and your normal will always lie in the same plane. For example, I take this as my reflecting surface. Okay. Now I'm going to incident ray in this direction. Okay. Now this is called as your incident ray. Now it reflects back. This is called as your reflected ray, and this is your normal to the surface. So the incident ray and reflected ray will be in the same plane. That means if incident ray is in XY plane, normal will be in XY plane, and your reflected ray will also be in XY plane. Clear? Now what is the second law? Second law states that the angle of incidence is equal to your angle of reflection. Now, how do we define angle of incidence? For example, if I take this as my reflecting surface, and if I draw a normal to this surface, and let me say the incident ray is coming and falling at this point like this. Now the angle made by the normal with your incident ray is called as angle of incidence. The angle the normal with your reflected ray is called as your angle of reflection. What this says is your angle of incidence is equal to angle of reflection. Clear?
Yes, sir.
So whether it's a specular reflection or whether it is a diffuse reflection, this law of reflection holds good. Okay? Why it holds good is because, say for example, it is like this, reflecting surface. Let me say the reflecting surface is something like this. And let me say the light is coming and falling like this. This is your incident ray. Now, immediately what you have to do is, at this point, for this surface, you have to draw a normal. Okay? For this surface, you have, at this point, you have to draw a normal. This is the normal for surface 1. This is your angle of incidence. Now, similarly, the same angle, if you take and you draw, you get a reflected ray. This is your angle of reflection. Whatever your surface or however your surface is, your angle of incidence is equal to angle of reflection. Clear? And as I said very clearly, if you want your reflected ray, what will you do?
Draw normal and
take the same angle on both the sides.
Yes. Take the point on the surface where your incident ray is getting hit. Okay. At that point, for that reflecting surface, draw a normal. Calculate the angle between your incident ray and the normal. The same angle down the other side of the normal you take, and from the same point you draw a line with that angle, you will get a reflected ray. Okay.
Yes, sir.
Now that we have studied about reflection,
Sir,
yes.
sir, 1 minute. Can you go to previous page, sir? Thank you, sir.
Now that we have seen what reflection is, let us go to reflection surfaces. In that, first I will talk about your plane mirror, which you actually see every day. You comb your hair, right? Uh, Actually, boys, you shave in front of a mirror. Your father shaves in front of your mirror, right? And everything. So that is called as a plane mirror. Clear? That is called as a plane mirror. The plane mirror will have reflecting surface on one side and it is silvered on the other side. So plane mirror means it has one side reflecting surface, the other it is silvered. Okay. Now see, let us understand with see this ray diagram. I'll try to explain you in one note. 1 second. See, whenever I take a plane mirror, okay. So plane mirror, as I said, it has one reflecting surface. The other surface is silvered. In few days, I'll tell you why. What is silvered means. They will put a silver paint at the back of the mirror. Okay. So when you put paint at the back of the silver paint at the back of the mirror, you will get a perfect reflecting surface. Now, see, if there is an object which is placed here, okay, there will be one way which is going like this, okay, one way which will go like this, that is parallel to your principal axis. I will tell you about your principal axis, focal point, principal point, radius of curvature, center of curvature when I come to spherical mirrors. But as such, you understand that travels parallel to principal axis will retrace the same path. So when a light ray which is there goes parallel to your principal axis, this is your principal axis, it will reflect back. Clear?
Yes, sir.
Now there will be a light ray which will be going like this and hitting at this point, right? So for this surface, this is your normal.
Yes, sir.
So if a ray is going like this and hitting, this will be your angle of incidence, right?
Yes, sir.
Obviously, it has to reflect with the same angle, law of reflection. This is your angle of reflection, right?
Yes, sir.
Until there is any doubt.
No,
Now
sir.
see, this, please once look at the image. From this is, let me say, the object. See, when a light ray goes like this, hits at this point, I said it will retrace back, right? Now, can I say this light ray which is reflected is coming from somewhere at the back of your mirror, from this point somewhere? Can I say?
Yes, sir.
Say this light ray which is reflected back is coming from one point on the other side of the mirror.
Yes, sir.
So this ray which is the reflected ray, it will appear as if it is also coming from one point.
Yes, sir.
Now see, there is a ray which is going at the foot of the image. Obviously, this will also retrace back. So if I go like this, right? So now from here, understood? So I'm taking one light ray which is going from head of the image parallel to the principal axis. I'll take this as, let me take O. Parallel to OP, there is one light ray which is going from the head of the object. There is another light ray which is from the foot of the object parallel to your principal axis, right? O-1 is one light ray which is going parallel to principal axis. OP is another light ray which is going from the foot of the same object onto the mirror, isn't it?
Yes, sir.
Clear? Now, from the foot of the object, there will be a ray which will hit the mirror at this point.
Yes, sir.
Yes?
Yes, sir.
Now, again, at this point, if I take normal, yeah, okay, this, okay, right. This is the problem with OneNote. Okay. This is the normal at this point. I'll take this as normal 1. I'll take this as normal 2. So this again will, light gets reflected like this from this point.
Yes, sir.
Right? So if I join this and go, it appears as if it is coming from this point.
Yes, sir.
So it appears as if there is some object here on the other side of it.
Yes, sir.
Yes, sir.
This is your image form. This is formed in the mirror on the other side.
So because it's normal, it's been the same on both the sides.
Your voice is very low.
Because it's plane, it'll be same on both the sides. The distance of the image.
The distance of the image will be on same, or it will be same from your mirror. I'll tell you all those things. First, did you understand the ray diagram?
Yes.
Please
Sir, I have a
always.
doubt.
Yes.
A ray which is passing through the normal same path, right? Not which is passing through the principal axis for a plane mirror.
That's what I said. Spherical mirrors, I'll tell you at that time, I'll tell you how it is. Any ray which is passing parallel to your principal axis will go through your focal point.
Exactly.
But for here, tell me what is your radius of curvature and focal point for your plane mirror?
So, but for a plane mirror, won't the normal retrace the same path?
Yeah, parallel to the normal in this case.
That's what. That's right now. Just take ray diagram. Once I tell you radius of curvature, center of curvature, focal point, principal focus, and all that thing, at that time, I'll tell you your reflection in spherical mirrors. At that time, again, I'll tell you plane mirror, why it is going like that.
Okay, sir.
Okay. Because radius of curvature is infinity for your plane mirror. Clear?
Yes, sir.
Yes, sir.
So, hope you have understood your ray diagram. So now you understood how your image is coming, virtual image, right?
Yes, sir.
So now see the nature of the image formed. Okay, first thing, it is virtual and it is erect. Erect means like this. Inverted means this
Narrow it
side.
down.
Okay, so this is called as erect image. This is called as inverted image. In plane mirror, if you see yourself, you will not see your image up and down, no? Right? So this is called as your erect image. So it is virtual, it's not a real image, it's a virtual image and it's a erect image. Okay. And the size of the object equal to the size of the image. So image, for example, I am like 5'8" height, okay, 5'9" let me take. So the image, my virtual image on the mirror will also be 5'9". Clear?
Yes, sir.
Not only height, the width wise also. Clear? So the size of the image is equal to your size of the object. Next, image is always formed behind plane mirror. Okay, image is formed behind the mirror. It's not on the same side of the object, it is on the opposite side of the object. So if mirror is there, object is here, image is always formed behind the mirror. Clear? Now, the distance between the object and the mirror, let me take it as u, will be equal to between the mirror and your image. I'll take this as v. So u is object distance. V is image distance. Clear?
Yes, sir.
Now, most important thing, your image is laterally inverted. That means your left appears as right and right appears as left. That is why on the ambulance, when you look, your ambulance on the front ambulance will be written in the mirror image form. So when you're looking at your rear view mirror, it will exactly appear as ambulance. Clear? Your rear view mirror is a plain mirror. Sometimes they will use convex. Your side view mirrors are, okay, I'll tell that when it comes to mirrors. They will write no on the side view mirror. The image is closer than what it appears or something, right?
Yes, sir.
Yes, sir.
So I'll tell you why they will write it like that. When we come to spherical mirrors, I'll tell you. Understood?
Yes, sir.
Yes, sir.
Ray diagram you have to understand. Okay, if you understood your ray diagram, plane mirrors are very simple. Now, if I have two mirrors placed at an angle, for example, this is one mirror, and I have another mirror which is placed at an angle theta. Okay, now let me say I'm standing somewhere over here, right? How many images are formed? Okay, if just see, if tell me this, if there is one plane mirror and you are standing like this, how many images are formed?
One image.
One image. If there is a mirror like this, remove this mirror. If there is a mirror like this and you are standing like this, how many images?
One image.
But
One.
now if I combine these two mirrors and if I place them at an angle theta, then how many images are formed? Okay, this has to go into your formula book. Okay, now what is that? Is, for example, if the value of 360 by theta it is becoming even. Now, for example, let me say the angle between two mirrors is 60 degrees. Okay, so 360 by 60 is how much?
60.
In 6.
6 is an even number or an odd number,
Even.
right? So the number of images formed are 5. Now you may ask me, so what is the symmetric asymmetric? Okay, what is symmetric and asymmetric is, if I take this image, if it is making an angle theta 1 object, sorry, if this object is making an angle theta 1 and if it is making an angle theta 2, theta 1, if it is equal to theta 2, then we call it as symmetrically placed. Theta 1 is not equal to theta 2, then they are asymmetrically placed. Clear? If you want, you can draw this diagram, theta 1, theta 2. Now, if your value of 360 by t odd, okay, if you want, you can take this one, 360 divided by 72. How much is it?
5.
Five.
It is odd.
Yes, sir.
Yes, sir.
And if it is symmetric, then the number of images formed are.
Four.
Sir, how do I know if it is symmetric? Use, if you have something in between your ears, you will understand it, right? 72, 36 and 36. Now tell me this. Is it symmetrically placed?
Oh.
No. It is asymmetrically placed. So what is this value? Can you tell me?
4.8, sir.
4.8.
Yes, sir.
So whenever it is 4.8, 4.9, 4.6, 4.4, 4.4, 4.3, whatever it is, the number of images found are 4 point make any sense, no?
Sir, should we not write 5?
No.
Okay.
So understood? Clear? Did you take this table and write theta 1 is equal to theta 2? Theta 1 not equal to theta 2, asymmetric. Easy to remember actually. Odd asymmetric only will have 360 by theta. Or else it will be all will be 360 by theta minus 1 only. Clear? Clear?
Yes, sir.
It's already 11. We have only completed 4 or 5 slides until now. Anyhow, so did you take this table? Shall I go to the next one?
Yes, sir.
Do the first question. Take down the question. Now, one more paper.
So is it 5?
Is it 7? Sir, is it 7?
Acha, I'm muted. Tell me I'm muted. No, I've been talking for last 5 minutes continuously.
7.
7. It's 7. See, I'm gonna break it. There are three mutually perpendicular mirrors. So what I'm gonna do is first I'm gonna take two mutually perpendicular mirrors. What do I mean by perpendicular?
Angle between them.
So if a point object is placed, how many images are formed?
3
3.
It is 360
by
by
90.
9, it
Minus
is
1.
4. 4
Minus
is
1.
an even number, right? And I'm assuming the point object is symmetrically placed. So images formed are
3.
3.
3 images. One image here, one image here, and the other image is at the
Center.
intersection of your mirrors. Now, if I put another mirror on top of it, okay. Now, these images will form one image there. 3 plus 3, which is 6.
Yes.
But this will again form an image at the intersection of 3 mirrors. So you will have total 7 images which are formed. Now tell me, if two plane mirrors are placed parallel to each other, images will be formed.
Infinite.
Infinite. Did you understand this? Huh?
Yes, sir.
What should be the angle between two plane mirrors such that whatever be the angle of incident, the incident ray and reflected ray from two mirrors be parallel to each other?
So in terms of angle of incident, right?
For any angle of incidence,
That's what
whatever, clearly they said whatever be the angle of incidence, the incident ray and reflected ray should be parallel. On your videos, Amma, how many are? Kavya, Darshan, Sharat, you will off your videos only when I tell you to off your videos. Zuvesh, Ajay,
Sir, it's 90.
huh?
Is it 90? Is it 90 degrees?
It is 20. But how did you do it?
I just took one mirror.
Oh my goodness. See, Okay, shall I give you 2 minutes time? I'll give you 2 more minutes. Try to do it.
Sir, I got the ray diagram. I got
Send
it
it
diagram. 1 minute.
ఏంటన్నా నువ్వా హాల్లో కూర్చొని చెప్తున్నా గో హాల్లో కూర్చొని చెప్పు ఇక్కడ వద్దు నాన్న ఇక్కడ వద్దు ఓకే హాల్లోకి వెళ్ళి చెప్పు తాతగా సిస్టమ్ దగ్గర కూర్చొని చెప్పు నో గో no go just give me 1 second no. Yes, Tanish, I told you to send me through WhatsApp.
I sent you, sir.
Send me. You send me. You just do it this and then you just said it's 90 degrees.
No, sir. The angle of incidence and the angle of reflection will be the same for both, right? If you take normal on the center.
You have to prove, Amma.
Okay.
See, I'm going to take one mirror, which is like this, and I'm going to take another mirror. Okay. So I'm saying these are making an angle theta. Clear? Until this it's clear?
Yes, sir.
Now, there is a ray which is coming and hitting here. Angle of incidence. For this surface, I'm going to draw my normal. This is my angle of incidence. So my ray will now go with the same angle and will hit here, right?
Yes, sir.
So this is my angle of reflection. One I'll take. Now, when it hit here, at surface, I'm going to take a normal. This is normal 1. This is normal 2. So I take this as my angle of incidence 2. So my ray will now have to go parallel to your incident, isn't it?
Yes, sir.
So this is my correct. So this I'll take it as point O. This I'll take it as O dash A B. What is angle AOO dash?
90.
90.
Oh, I1 plus R1.
What is your angle BO dash O?
I2 plus R.
plus R2.
Right?
Yes.
According to law of reflection, I1 and R1 are same. Can I write it as 2I1? I2 and R2 are same. Can I write it as 2I2?
Yes.
Now, what is the angle between AO and O dash B?
They're parallel, so it's 0 degree.
This is going in this direction, this is going in opposite direction. How can it be 0? Right? So can I say 2I1 plus 2I2 should be equal to 180?
Yes, sir.
So
Correct?
Yes, sir.
So I1 plus I2 is
90.
90 degrees. So this I can write it as R1 plus I2 as 90 degrees.
Yes, sir.
Yes, sir.
Now see this. This theta, carefully look. This actually is mirror 1. This is mirror 2. The mirror 1 is making an angle theta with mirror 2. The normal of mirror 1 and normal of mirror 2 will also make the same angle theta.
Yes, sir.
Right? I take this point as C. So O dash C is a triangle.
Yes, sir.
Yes, sir.
If R1 plus I2 is 90, what should be your theta?
90.
Clear?
Yes, sir.
Now do you see the difficulty in ray optics? See, physics is very, I'll tell you why physics is peculiar. If I roll a ball towards you, okay, you are sitting on the other end of the hall, I'm sitting on the opposite end. Imagine we are two kids playing with a ball. So small, we cannot throw the ball, no? We'll be pushing the ball like this, right? So the ball is coming and rolling and coming to you. Suddenly, I came and said, prove that ball is rolling. That's physics. Mathematically, if you can prove that the ball is rolling, that is physics. If you say ball is rolling, it's spirituality. So physics and spirituality is same. Proving spirituality is physics.
But the diagram
Over?
was same.
Huh?
So 1 minute.
The diagram we sent you was same.
Same, but this is, see, that's what I said. Diagram which you sent is correct, but this is mathematically you are proving it. See, ray optics will appear to be very easy, Amma. But when you try to prove it, then you will see the real difficulty in that. Understand? I can frame 1,000 ray optics. And remember, not even one question is repeated in last 20 years of JEE mains or AI triple or anything. So imagine how many number of questions can be framed.
Sir, only from ray optics or all?
Yeah, all chapters. A boy 1.5 meter tall with his eye level at 1.38 meter stands before a mirror fixed on a wall. What should be the minimum length of the mirror such that he can view his entire body? Now I see how many of you are very good at trigonometry and mathematics.
1.5?
What is it?
1.5?
No. Draw your ray diagram first. Come on. Still, we need to do some more numericals. Tell me this. We know I is equal to R, right?
Yes, sir.
If this distance is X, this distance is Y. What is X and Y?
X equal to Y.
Fantastic. There is a reason why I asked you this. Okay, I'm doing it.
So is it 1.3?
No. See, this is your mirror, which uh, it is placed on a wall. Okay. Now, what I will do is I'll take a boy of 1.5 meter tall with his eye level at 1.38 meter stands before the mirror. So if I take okay, this is the eye level of the boy, right? So let me say this is the face of the boy. So he's standing in front of the mirror. So from here to here, what is your distance?
0.1.
0.12.
Okay. Now, from here, let me say the boy stands. So basically, he'll go like this down somewhere, right? Right? This is his foot. Correct?
Yes, sir.
So let me put his face something like this. Hands, legs. Ah. I'm very bad at drawing. So let me say these are his legs, and this is how the boy is, right? So this is his eye. The eye level is matching the top of your mirror, correct? So now see, if he needs to see his head, right? Correct?
Yes, sir.
So now that you have understood the diagram, I'm going to draw just, I'll take red and I'll draw it. Let me take, this is your boy, okay? Um, The light ray has to come, hit the mirror at this point, and then come in this direction. Right? And the boy eye, which is here, can see the head.
Yes, sir.
Yes, sir.
Clear?
Yes, sir.
So I'm drawing the normal to the point here. So if this distance is x, let me say, what will this distance be?
X.
X.
Okay. So this total is 0.12. So this is x is 6 and 6. Later I will substitute them. Okay. Understood? Now, a ray has to come,
Again, he hit
hit the
them.
mirror here from the foot. From the foot, a ray comes, and it will reach the eye. So when you stand in front, one ray from your head is going to the mirror, coming to your eye, right? And one ray from your foot is going into the mirror, hitting it, and then coming, right? So I'll take this distance as y, hence this distance will become y.
So the answer is 0.75, right?
Now, this ray appears as if it is coming from one point over here. This ray appears as if it is coming from one point over, right? Hello?
Yes, sir.
Yes.
This ray appears as if it is coming from another point somewhere here.
Yes, sir.
So this is your image formed. Clear?
Yes, sir.
I'm taking this as M dash mirror. I'll take this as image I dash. Is it clear?
Yes, sir.
Yes, sir.
Ray diagram is clear for you. If ray diagram is clear, then
Yes, sir.
okay. Now triangle EMM dash and EII dash are similar.
Yes, sir.
Yes, sir.
Yes, sir.
So M dash
By
divided by
I.
I dash is equal to, tell me, M dash divided by I dash.
So EM by EI.
No.
So VM by EI.
I'm gonna draw a normal like this. Right? This I'll take it as O dash. M dash divided by I dash will be equal to EO divided by EO dash.
yes, sir.
This will be EO divided by 2 times of EO. Clear?
Yes, sir.
Hello?
Yes, sir.
Yes, sir.
Yes, sir.
EO gets cancelled. This is half.
Yes, sir.
M dash is equal to I dash divided by 2.
Yes, sir. 1.5 by 2.
We know plane mirrors, the size of the image is equal to your
Size of the
Size of the
Size of the
object.
object.
size of the object.
Object.
So this is your height. Height of boy divided by
Sir,
yes.
or can we do 2x plus 2y is equals to 1.5? Like rather taking this whole diagrams in this, we got x, y, y, no, sir. The total distance is 1.5. So
The
2x,
total distance 1.5.
yes, sir. So all, if we add all of them, we get 1.5.
Yeah. So
2x
x
plus
plus
2y is equals to
2y should be equal to 1.5. So x
yes,
plus
sir.
y is equal to 0.75.
0.7.
You can do that also.
Yes.
I will always tell you the difficult method. Easiest method you have to check. This is also not difficult method. Basic trigonometry, geometry. See, they are trigonometry and geometry, nothing else. Clear? An object is moving towards a stationary plane mirror with a speed of 2 meters per second. Velocity of the image with respect to object and with respect to mirror.
Sir,
So
4.
with respect to mirror, it be 2 only. No?
Okay.
So is it 4 and 2?
Hmm. But tell me directions as well. You told me the magnitude. Now tell me the directions.
So the object is moving towards the right.
And image is going towards the left.
It will become
Hmm.
lower and
See, this is your mirror. Did you take down the question?
Yes, sir.
This is your object. Let me say object is running towards your mirror with 2 meters per second. Now we know the nature of, so your image is somewhere here. So let me take this as V. Let me take this as U. We know your object distance is equal to your image distance.
Yes.
Reflection
yes,
of
sir.
plane mirrors. Differentiate both sides with respect to time. du by dt
A is equals to
is
dv by
equal to dv by
dt.
dt. That means your object velocity should be equal to your image velocity. Okay? So if it is moving 2 meters per second towards the mirror, then if you move towards the mirror, your object appears to be moving towards you, right?
Range, yes, sir.
Yes,
Yes,
sir.
Yes, sir.
Correct. So velocity of object with respect to mirror is 2 meters per second, which is 2 I cap, right?
Yes, sir.
So velocity of the image with respect to mirror will be
Same.
2j cap.
minus
2j minus 2 I cap.
Minus 2.
minus 2 I cap. So
Yes, sir.
velocity of image with respect to object is velocity of image minus velocity of object. So velocity of image is how much? Minus 2 I cap. Minus velocity of object is how much?
2 I cap.
So velocity of image with respect to object is 4 meters per second towards object. Velocity of image with respect to mirror is velocity of image minus velocity of your mirror, isn't it?
Yes, sir.
Velocity of image is how much?
Minus 2 meter.
minus
2
2.
I cap.
Minus velocity of mirror is how much?
0.
Or 2 meters per second towards the mirror. Clear?
Yes, sir.
Two bodies moving in opposite direction with respect to each other. Relative velocity is
Subtraction. You
Clear?
add the magnitude.
you have to add the magnitude. Clear?
Yes, sir.
Yes, sir.
I think you can do if mirror velocity is given, right?
Yes, sir.
if velocity of object is 15 meters per second at an angle 45 degrees for plane mirror, then velocity of image with respect to mirror.
Fifteen by root two
Hmm.
in minus I cap direction.
Did you take down the question?
Sir, 15 by root 2.
So your object is shown with a velocity or velocity of the object is 15 meters per second at an angle of 45 degrees for plane of the mirror. For plane, not plane mirror, for plane of the mirror. So if this is your mirror, this will be mirror, it is making an angle 45 degrees, right? So the velocity which is coming towards your mirror is
V cos theta.
V cos.
so this is 15 by root 2 meters per second is your velocity the mirror will take. Hence, image should also come with a speed of
minus 15 by root 2.
15 by root 2 meters per second. Right?
Yes, sir.